Hello, and welcome to Introduction to Bioinformatics Analysis, a course taught by Phillip, Richmond. This is section 1-4, Advanced Linux and Unix. So forward for this presentation, if you have not watched and gone through section 1-3b, then I highly recommend you go back and do that section first. Also, the cheat sheet is very nice to have out. Pretty much for the rest of the course, it's good to have either a paper copy of that cheat sheet or the PDF on your computer. Quick start instructions. Again, you should be familiar with this process already. We're going to log in to the server. So we're going to practice a couple things in this section. The first one is getting a file from the World Wide Web, or fetching a file with Wget. So why don't we first make a new directory within our sandbox called downloads. So we can go to our sandbox directory /global scratch wrc. I'll go to that one, and we can see that this is we've got some files here that we were playing with from earlier in section 3. So I want you to make a new directory here called downloads. So you can make it with all caps or all lowercase. Sometimes it's nice to use different capitalization for directories than you have for files. Again, this is all just preference. Okay, so we've made our downloads location. So why don't we next go to the browser and open up the SGD homepage. Hopefully most of you that work in the yeast genomics field have been to this site before. If not, it's a great resource. Just type yeastgenome.org, and this will take us to the Saccharomyces Genome Database, or SGD for short. Come on, SGD, you've got it. Here we go. SGD. Okay, so there's a lot of different resources, usually some nice recent publications in the news on the right here. So we're going to go to, what we want to do is we want to make use of the files that they host for download. And so one way to get there is to go over to Sequence and then go to Download. And what I want you to grab is go down to the strains and select this wine yeast. So we're going to scroll down. You can see that we've got, this is where I got the data for the S288C reference genome. But if we scroll down, we see that underneath strains, they have several different sequence strains that have their published genomes and annotations. So if we click on this strain here, this folder, it will take us to their FTP server. Come on, Wi-Fi. Do 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 do. You can blame the rain for this. Let's give it another try. Here we go. Okay, so then you enter into this page, and we want to go one more down into the directory, and we want to grab all of these different files. So in order to do that, we use wget. So the easiest way that I have been doing this is, let's just start with the README file. So what you can do is, if you click on this link, it will download it to your computer. But if you right-click on it, you can copy the link location, and then the wget command will you can copy paste the link there, and if we hit enter, then this file was just downloaded into our directory. And if we type ls, oh, it went into the wrong spot. I want it to be in downloads. So we can move it there now. And why don't we change into the downloads directory for the rest of these? So then I'll go back here. I will copy the link location on the second file, wget, paste. This file is a little bit larger, but as the files are bigger, you will actually see this progress bar slowly move. But with yeast, the beauty is that the genome is small, so we do not have too much time to wait when we download files. If you work in other organisms, this is definitely not the case. And the last one. Okay, so why don't we type clear and take a look at what we have in this downloads directory. So the first thing that you're going to notice whenever you download files from the internet is that they are going to be compressed. And so there's many different types of compression. These files are compressed with a compression type called gzip. There's also BZ2 and tar and different combinations of compression. And honestly, the best way to figure out how to unzip a file is really just to Google it. Even after years, this is still what I do. So we can now practice just Googling a simple question. So why don't we go to Google, and we will ask how to unzip a .gz file in Linux. Okay, so it looks like I've actually already been here. We can go ahead and take a look at this first one. Maybe this we can use. Usually they do. Don't know why the internet is being so uncooperating with me this morning. Anyways, the file that this, or the command that this link is going to give us is going to tell us to use the gunzip command. So honestly, being able to Google these different commands or Googling a question and using the resources that are available to you is one of the best ways to expand your bioinformatics and Linux experience. So we will type this command, gunzip. Why don't we go ahead and unzip this file. And then if we type ls, you see that now it is no longer zipped. And in fact, if we do an ls-l for one of the next files, you'll be able to see the change in file size. So ls-lh, we can see, why don't we unzip this file next? So it is going from 3.3 megabytes, gunzip, to now it is 12 megabytes. So it's about a 4x compression. Oh, look, it finally was able to load, and you can see how do you extract a GZ file, gunzip, then the file. Simple. So gunzip, we'll go ahead and do these next two. So ls-l, now they are all changed so that they are all, we're able to read them. If instead we were to try and do a more on a compressed file, it would spit out binary. In fact, why don't we go ahead and go back to a wget for one of these. So now you can see that if we were to do something like a more, on one of these files, that it is what we call non-human readable. So this is what happens when you try and use a command like more on a binary file. You get lots of weird, crazy characters that you probably don't know how to interpret at all unless you speak computer. So we are going to stop looking at that file. It's entirely unhelpful. But I was just showing you that, again, you can see the difference in file size, and if we were instead to do a more on the uncompressed file, this is something that we can actually read. Documentation is very important. When you go to publish or when you go to share your results, you need to know things like what version of the genome you were using, where you got the files that you were using for your analysis. Several times when you're in the publication process at the end of a project and your documentation is poor, that might mean you have to rerun all of the analysis with a reference genome that you can actually cite exactly where you got it. This has happened to me before. It is not fun. So documentation is very important. This should be done off the server somewhere, but additionally, it's good to immediately document on the server. And so in order to do that, we're going to need to use an editor. There are many different editors available: VI, Emacs, Nano. There's probably a few more that I don't know about. But the idea of all of these editors is that they are installed on the Linux server. Now, the one that I'm going to use in this class is one of the most popular and easy ones, and it is called Emacs. And we can edit a new file by invoking the Emacs editor command. So we can type Emacs and then the name of the file. We'll call it readme.txt. And now we are within the editor mode of Emacs. So I could type something here. But what we really want to do is we want to type something useful within this README. Having a README in every directory is good practice, but having a README next to files that you downloaded, I think, is required. So we are going to go ahead and type within the editor that exactly where we got these files. So we got these AWRI1631 files from, and we can again just go back to where we got them. Copy paste into this editor, and we got these on June 23rd, 2016, or whatever date it is for you. Okay. Now, in order to save and then exit, we can hit Control X, and you can see it's starting to pop up down there. Control C. Now it's asking us, do we want to save this file with this full file path? And we can go ahead and type Y, and then it's done. So now, if we type ls, we can see that we have created this file, and we can look at what we've created. This is exactly what we typed into there. So that's all that there really is to editing. For more Emacs help, this is a pretty good walkthrough on several different commands of how to use the Emacs editor. Things like finding or replacing strings, lots of different commands, moving or navigating a file, searching a file. All of these things are things that you might imagine you can do within a simple text editor on your computer. Emacs has a lot of those capabilities as well. Okay, so The last thing we're going to finish with is how to copy a file to our own local computer. Oftentimes it's very important that we transfer between our local machine and a server, and really the easiest way to do this is to use one of these two, we call them secure transfer or SSH or FTP clients. And so these transfer clients for Macintosh, I recommend CyberDuck. That's the one that I use. It's this little ducky right here. If you're on Windows, I've also used this program, WinSCP. It makes it very easy. If you would like setup instructions for these, I can help you in person, but it's very simple. You really just need to select an SSH or SFTP and then use this info, the server address. You're going to have to enter your username and your password and leave the default port 22. Now within this video I'm only going to show you how to use SCP for Mac users. If you are a PC user, I think that the only reasonable way to do this is using WinSCP. Otherwise it gets very complicated. So secure copy. We are going to secure copy the file, one of the files that we just downloaded onto our computer. So we could do this most easily by opening up a new terminal. So if you hold Command and hit N, that'll open up a new terminal window. I will enlarge it for you guys. Okay. Now, what we want to do is, if you're on a Mac and you want to practice some of your commands, we can simply use the same commands that we were using on the server on our own computer. So we can, why don't we change into desktop? And when we change into desktop, you can see these are the things that are on my desktop. These are actually these different files. So if we type clear, we have a nice clean screen. And so when you are using the SCP command, it follows a very specific format. So that format is SCP user at host address colon file path to copy the file from space user at destination address colon file path to send the file to. If you are moving from a server to your local machine, you don't need to specify the user at destination address. So we could just specify the current directory. So what we'll do now is we will first find out where the file is. And so this is usually best to do with copy-paste. So we want this file path. So what we'll do is we'll type SCP, our username at server colon, this is the file path, the file that we want. Let's go ahead and transfer this file, and we want to send it just to our current directory, which is going to be our desktop, which is mentioned there. And so if we type enter, it's going to prompt us for our password because we are connecting to a secure server. And then as it copies, you can see the progress here. And now, if we go over to our desktop, there's the file that we just grabbed. Additionally, if you go over to the desktop You can see on the Finder, the file is now there. And the last way to check, we can see that our file is on our desktop just using the ls command. That's all there is for this video. Goodbye.